right. I am here with Jason Corso, professor of robotics at the University of Michigan and founder and chief scientist of Voxel51. Thanks for coming on the show today.
Thanks, Eric. It's a pleasure to be here.
Yeah, great to have you. I don't get too many, doctors and PhDs in any scientific field, so it's really cool to get somebody who is a true, expert in the field as opposed to us business folks who like to take the hard work that the engineers do and figure out how to use it to make money. But anyway, I digress.
Well, I hope I can provide some useful insights, but the letters after the name are only letters. You really have to, every day is a new day in which you have to prove yourself, right? So
that's right. Wonderful. Well, I'd love to just hear a little bit about your journey and ultimately what drove you to form your company.
Absolutely. So I guess I'd probably characterize myself as a builder by nature. I really just enjoy kind of creating things. I think it's what pulled me to academia in the first place. It's often described as every individual faculty member at a research university is a startup owner of their lab, right? You got to fund it, you got to manage it, you got to deliver output and so on. And over time, I had always been involved in various consulting opportunities. Code I've written, for example, is I think still in production at a bioinformatics company in Connecticut. I have a license for GPU-based CT scan reconstruction and so on. But I guess I wanted to do a little bit more. We can write papers. I've written a lot of papers in various aspects around the triangle of humans, visual perception, and the physical world. I began to see, or I guess ask questions like, can I have a bigger or broader impact? Even though I was open sourcing data sets, open sourcing source code, writing papers, was there more that I could do? I met my co-founder actually in one of my computer vision courses in 2014. So Brian Moore was the kind of student sitting in the front of the classroom, always asking questions, making me stay on my game and so on. And we stayed in touch after that time. And I guess we were collectively interested in is that this sort of confluence of possibilities, right? Video was ubiquitous. Capabilities of modern machine learning were off the charts. And this was 2017, 2018. And we both like to write code. So what more do you need than that to start a company? So we actually began as, I would call it kind of we transitioned from the academic world, if you will, into a consulting style of company as well. We were initially funded as a grant by a grant from NIST for video understanding. We thought there was going to be a good potential in turning that generating, you give us your video, we'll give you insights into that video, and you give us the money, and it's all good. And it worked out pretty well for a while in the sense that we were able to generate insights from video right before you had GPT-4v, whatever. This was 5 years ago. However, we realized we were quickly becoming a consulting company, not a product-based company, which is what we wanted to do. And we were having to build, we built a lot of machinery for building out that this notion of domain-specific video understanding was necessary, right? So one for insurance, one for automotive, one for physical security, and that just was not scalable. So we ended up, once we decided to actually go after VC funding, we pivoted into earlier on in the life cycle where we thought there was going to be a huge need around how you actually build out these capabilities, right? How do you build data sets? How do you build models? Oh, and it's not really just go get data and train a model and you're done. It's this notion of co-development of data sets and models together to actually render out this performant machine learning system. And ultimately, those learnings, after talking to quite a few potential users and customers and so on, led to what Voxel51 is today, right? So we have this main software package called 51, which is open source, has about 2 million downloads, and it really facilitates that notion of co-development of data sets and models together from an unstructured computer vision or even now 3D field. We wrap that open source offering with an enterprise offering. By way of analogy, open source is kind of like Git, one user, local data in some sense. And the enterprise version is whenever you want to collaborate or do things in the cloud, you kind of use the enterprise version.
Okay, so if I'm an app developer, what's the situation or scenario where I would look to Voxel51?
Yeah, whenever there are actually two different angles to that question. So one is right now, whenever you are building that app that you're building, say it's, I don't know, counting coffee cups in a coffee shop, or managing the frequency of packages going down like a UPS assembly line or whatever, or sorting line. Whenever you're building a visual AI or unstructured AI system, and you need to train your own model, like there's no off-the-shelf model you can just download, and for that model you're actually getting some data, like that work of like collecting the data, connecting it to models, understanding how the model's working. 51 is really like a sandbox for playing with different model architectures and hyperparameter tuning, and it really enforces this notion that only looking at the aggregate precision recall or aggregate accuracy scores on whatever benchmark you chose, that's not enough. Like, in order to really train performant AI systems, you need to understand how the model performs at the corner cases, right? Like, you can do well at the mean plus minus a couple sigma of the distribution. That doesn't matter. Anyone can do well on any problem, mean plus minus 2 sigma. The real performance systems out there do well at the tails, and 51 is a solution to help you understand your tails better in that sense.
So I imagine for something like self-driving cars, that would be really important.
Yeah, we have many of our open source and paying customers are from major automotive vendors for those types of problems. In fact, I won't name the company, but one of them was like music to my ears. Right, this one person was telling us, he and his team had been working with this large data set for over a year, and he discovered 51 and took something like 1% of the data, I don't know, some thousands of images, and within just a few hours of playing with that data set, that subset of the data set in 51, he was able to find dozens of mistakes in the data, right? And it's just this notion that, like, we feel like, when I was a grad student 20 years ago, my data set's numbered in the dozens. I could manually look at all of those samples multiple times per week when I was doing experiments. And there's just this human fragility, I guess, or unwillingness to look at millions of samples, because that's millions of samples. I don't have that time. You don't have that time. So what 51 really lets you do is just ask questions about your data and then shows you the answers visually. And it really unlocks that notion of sort of getting close with your data to really understand how it's distributed. Yeah.
Yeah, I won't name names too, but I worked as a data scientist and led a data science team for a very large corporation. And I will admit that there was a step in our process that is randomly sample the data and look for mistakes.
Yeah, exactly. So that's kind of like the lower bound on your performance, right? Like, in some sense, at least you were looking at the data, so that's great. But if you could do just better than random, even just a little bit better than random, your work would have been faster. Or in some sense, like, you can kind of think of the work of a data scientist as like iterating through, do things with data, do things with models, cross your fingers and really hope for the best so you can deploy, but it doesn't work. So you got to go back to do things with data. And 51 kind of just lets you like iterate through those processes better. Like, you might even interject like an analysis bubble in there, right? Like data, models, analysis. Like, I just think it's the right way to approach the problem.
Yeah. And I mean, it always sort of has been, but in any data science or AI machine learning type of environment, the quality of the data is the most important, even more important than how sophisticated the system is itself, because garbage in, garbage out, essentially.
Right.
And so any tool that can actually streamline and automate the sanity of the data is incredibly valuable and time saving.
Yeah, I definitely agree. Although there are, in some sense, there is still this unknown question, or we don't know the answer, right? Like, is it better to have a smaller, higher quality data set, or a larger data set with a lesser quality? And if it's better to have the larger data set with lesser quality, I'm not aware of sort of principled mechanisms to diagnose how much lesser quality we can deal with in order for that to be okay, versus, the other side, okay, just throw away some bad samples. Like there's one problem that I've been interested in, which may be too technical for the blog. We'll see for this podcast here. We'll see, right? Like this notion of best subsets, right? Like, so if you had like 1 million samples to possibly choose from, and you wanted a compute budget of only 10,000 samples, what are the best 10,000 samples to use for your work? Is that a better problem, like doing the work of choosing like 10,000 unlabeled samples from the 1 million unlabeled samples? Is it better to do that because you're going to spend money on that compute? Or is it better to just choose 20,000 samples and get them all labeled, independent of whether or not they're the best or just randomly sampled subset of the data? I find that problem to be fascinating. Honestly, running a company for the last 5 years, haven't had much time to concretely dig into it, but like, I think those are the types of questions that will provide good insights for how to navigate through the really murky quagmire of principled or just more data from a machine learning standpoint.
Yeah, well, so from my perspective, being in a large enterprise or dealing with large enterprise data sets where we can actually kind of control for some accuracy, we don't mind overfitting the data a little bit and maybe losing some of those edge cases as you were talking about, because we're not talking about taking a video of a street. We're basically looking at, our manufacturing line, right? Something that just is a little bit more predictable. Whereas a lot of these other, again, these systems that you're just taking video or photos of things out there in the natural world are just naturally going to be a lot more messy and murky. And you've just got to be able to deal with that flexibility. So a more robust system that can handle more garbage, essentially artifacts, I would lean in that direction. So I guess my opinion is it depends.
Yeah,
as with everything.
I get it. I guess and I do hear that from many of our users as well. This notion that we have a constraint setting, right? Like we don't need to deal with everything, every possible thing happening. But when I hear that, I mean, I totally agree, right? Like it's a wonderful situation to be in to not have an open world, right? Yeah. However, I think there are scenarios in which, as we relax some of the constraints in these even closed world settings, you may or other users may want just a little bit more out of their system. So I do wonder. In your experience, I don't know, maybe I can ask you a question. Like, I have found success in humans in the loop in those settings, right? Like, even in an inferential loop, right? Like, okay, have some way of training a system in which, we're confident to 95%. So 1 out of 20 samples, we need to send it to a human just to make sure that, that's going to be the right answer that we want. And in fact, this actually gets back to the other types of app builder question that you were talking about earlier. But anyway, maybe we'll get back to that later. But do you find value in having a human in the loop in certain inferential settings to fill in the gaps when the system is less certain, maybe?
Yeah, well, again, there's scenarios, right? Like, so it's obviously something that doesn't scale well. But I will say that, as a domain expert, but any domain expert, you get this sixth sense about the data where you can look at it and it just doesn't feel right. And I don't know how to explain it. And I'm sure there's some, mathematical or computational way to map to that feeling. But I can't say how many times I've looked at a data set or looked at some analysis and be like, there's just something off here. I don't know what it is. And then I'll dig into it and I'll find something. And I couldn't have predicted that scenario. I mean, if I had, I would have coded that in. So I didn't predict the scenario. I didn't, all the checks, all the data validation scripts and everything came out okay. But there was something that just felt wrong. And when I dove into it, I found some issue. And that kind of thing happens a lot. And then it depends on, how much you care about it's risk mitigation, I guess, at some point. So there's this balance between, again, how scalable do we want this thing versus how much do we want to control for risk?
Right. Humans are really good at pattern matching and pattern recognition without really being able to capture why we feel a certain way about a certain pattern, right? Like I'll map it to the NFL, right? Like the best head coaches, the best offensive coordinators, and the best defense. Like I think there's certain situations in which they don't know why they're choosing a certain configuration or certain play. And you can, if we want to get principled about it, right? Like it's, data lives in like ridiculously high dimensions.
Mm-hmm.
Modeling data distributions of such high dimensions is very difficult. So difficult to the point where, there's some papers in the computer vision literature like, our nearest neighbor is all we need. It's like basically like when you get to have such a high dimensional distribution, you'll never be able to fill it out to really get a good understanding of all those dimensions. So like, do humans actually think in those high dimensions, or are we just really good at understanding these like low dimensional substructures that are there and just not able to like characterize what those spaces are? It's hard to say.
Yeah.
If only, like I have a great colleague here at Michigan, Laura Balzana, whose focus is all about like taking distributions of high dimensional data and then trying to discover those low dimensional substructures in that space and actually being able to characterize those. I think that's a rather compelling direction for the broader machine learning or signal processing field. It's funny, I'm reminded of these. I don't know if you've been watching the Jack Reacher series on Amazon Prime, but it got me to listen to some of the other stories that were not converted to TV yet. And Reacher, the main character, often talks about this like feeling in the back of his brain about some setting that's not right. It's the exact thing that you're talking about, right? Like,
yeah.
Anyway, yeah.
Yeah. No. Again, we have this incredibly powerful pattern matching system in our brain, but it doesn't always connect to everything else. I think that's where I feel like it's a sixth sense. Is it's not logical, it's not connected. I don't know why it is, but there's just something in there. It's like there's a little red light going off in that part of my brain that says, "Curious, maybe I should look into this."
So I think you just gave me a new tagline for 51, right? Like I'm a technical person. My co-founder's technical. We struggle with marketing. We're so grateful to have some marketing people on the team that we hired who are experts in the space. But like, 51 is the AI software to unlock your sixth sense. I think that's like the way I would think about it.
Yeah. Wonderful. Yeah. So I want to shift gears a little bit because this is a topic that comes up a lot in the podcast and in conversations as well. Is really the technology in AI is developing so quickly, and people it's obviously the Wild West, and people are trying to make sense of all these tools. And the question that always comes up is like, what are the new applications, the new opportunities that are available to us now that wasn't available to us, even just a few years ago? And actually, so yesterday on my Sunday afternoon, I was researching the new Google Gemini that they've released. And essentially it's, video, computer vision opportunity. So basically, for those who haven't seen it yet, you should definitely go check it out. They're integrating it into Bard now, but it's a full multimodal AI that you can, and they streamed they did a live stream where they took a video of, drawing a picture of a duck and, oh, this is a duck. And okay, now I'm going to take that duck and I'm going to put it on a map. And, oh, that duck is in the middle of the ocean and it won't find any of its buddies there, any food or anything like that. So it was this very reactive, very natural interpretation that the system was doing using video. And of course, this is like the first look where obviously my mind is just going like, okay, what is this? What does this change? What does this mean for us? And the audience being mostly entrepreneurs and sort of technical startup founders, I'm always looking at, okay, what's at the very tip of the spear of technology that's become available, and how does that create opportunity or change the game for people in business? So what are some of those brand new applications that you're seeing out there?
Yeah, well, I think 2024 is, I did not coin this, but I think it's definitely the year of like visual AI, as you're alluding to here, right? Like there seems to be just enough capabilities that have matured to the point of suitability, at least in interactive settings, like like DALL-E or something like that, or even like Gemini, like kind of creating video or creating images where, it doesn't have to be perfect. It's not like you're doing, cardiac surgery, and if you get a millimeter off, the patient dies or anything like that, right? Like, so I do think the first type of application is among that we will see, or that we are seeing, is definitely among these like creative settings. Whether or not it is like given the, you're making a presentation, right? Like, and you have the topic of the presentation. Okay. Then you can have a creative assistant alongside of what you're doing. And it'll not only change the look and feel of what you're doing, but also recommend different flows of ideas and different auxiliary artwork, or even other papers or recommendations for it. I think like that notion of creative AI is really greenfield and nascent and exciting, right? Like, but let's see some other things. One thing I'm not seeing, but if I was going to start a company tomorrow, I would probably do this, right? Like if you take the confluence of like the Apple Vision Pro or any other mixed reality or augmented reality, right? Like, Apple's getting a lot of press, but they're far from the first of these capabilities to, even, frankly, I wrote a doctoral dissertation proposal in 2003 on mixed reality because I thought it was going to be the next big thing, and it was a little too early for that. But so I think, right, like for education, like mixed reality plus like the Gemini type Gen AI capabilities, or DALL-E type Gen AI capabilities, right? Like, word problems and understanding mathematical structures or physical concepts for, STEM education is ripe for that type of like on the fly creation of interactive examples.
I will say, I called my daughter into the room because I'm the resident math teacher at home, and I'm always being pulled into to correct or coach her on her homework. And they showed in the webinar them taking a picture of handwritten math problems, and it was actually giving them not just corrections, but even coaching and tutoring in real time. And so I was like, we're gonna have to try this out. I'm gonna have to show you how to use this, because I get a little frustrated.
Yeah. So that is exactly the type of thing where I believe it will be. That to me, that application alone is a game changer, right? Like for that type of mixed reality, Gen AI style work. And I think maybe a third, just to maybe round it out at 3, would be maybe a little less popular, but even like back to last year's big wave of innovation with LLMs, right? Like, I think that no one's gonna question the ground that broke, that those ideas broke, which is just so compelling, so amazing. But I think the real impact of those language-based models is that they will bring, as technology has improved and capabilities in computation and information and so on, and accessibility have increased, I feel almost like in some ways I'm slower on the computer myself. And like, it's like you have to do more to get more out of it, right? Like, or maybe another way to put it, right? There's so many information systems that we have to interact with on a daily basis that it's almost draining, more draining. I think the next best contribution of LLMs will be to shrink those bridges and actually bring more information to your hands more quickly, based on context, based on questions. Even if it's just like better web search, that alone will be useful. But I do tend to think there will be a revolution in more sort of like on-demand agents that you work with to help go and pull information from your own ecosystem and bring you the information presented in the right format in a quick amount of time.